Bismillahirrahmanirrahim. In our previous lab activity, I started off the basic concepts regarding the identification of unknown organic compounds. If we give you any compound in the lab and ask you to identify the nature and the structural features of that compound, how you could proceed. That very aspect, you guys will need to start with the performance of the litmus solution test. Let me write the topic here: identification of unknown compounds. It could be something like that, or it could be your products. Let's say you have produced any product during a chemical reaction and you want to find out the nature of that product. You can also perform the simple wet lab chemistry test in order to find the structural aspects of the compound. Let's say once you are working in the synthesis of synthetic dyes, you are producing certain dyes, especially the azo dyes. You can prepare those very easily in your labs. After that, if you want to elucidate the structure of the dye, then different conformity tests could be performed as per the basic principles of wet lab chemistry. So in the identification of compounds, we started off that we should perform the litmus solution test right at the outset of the lab activity. It confirms either your given compound is acidic in nature. This is what we discussed. Or the given compound is some sort of a base. I could write basic in nature, and that very class is supposed to be amines as far as your course is concerned. Thirdly, the litmus solution may come up with the result that the given solution is some sort of neutral entity. The neutrals are supposed to be the carbonyl compounds, or they could be carbohydrates. Two categories were supposed, explained in our last lecture as a part of basic concepts regarding the lab activities. When we moved into the acidic nature, once you perform the litmus solution test on any unknown compound, the litmus solution confirms the given compound is some sort of an acid. Then I explained to you guys those acids could be only of two types. They could be, number one, they could be either carboxylic acids, or they could be phenols. Once you fall in acidic category after the performing of the litmus solution, if the result predicts the given compound is acidic in nature, it can be either a carboxylic acid or a phenol. Then further confirmation could be done by using very much known sodium bicarbonate test. It confirms the carboxylic acids, presence of carboxylic acids. The phenols could be confirmed using neutral FeCl3 test, it could be confirmed using this one or it's using this one. These tests are supposed to be performed once your litmus solution confirms the given compound is acidic in nature. What happens in these compounds, in these tests, when you perform sodium bicarbonate test? Let's say you have a test tube here, you put in your organic compound which is unknown to you, you don't have an idea what is that, and then you put in sodium bicarbonate solution. Sometimes you gently shake it, sometimes you need to do a bit heating as well. Then the evolution of CO2, effervescence. CO2 evolves from the test tubes. It confirms the given compound is a carboxylic acid. That's the confirmation, predicting that the given compound is a carboxylic acid. However, then what happens actually inside the test tube? Why CO2 is evolved, from where CO2 is generated, that needs to be looked into. So I'm going to explain the basic chemistry of these tests now. I will explain the chemistry of the sodium bicarbonate test. Before that, I think I should explain the bromine water test. In my previous lecture, I explained to you guys the bromine water test confirmed the presence of unsaturation, means the presence of double or triple bond in the given unknown compound. That could be identified using bromine water test. What happens in bromine water test, that needs to be discussed first. Bromine water test can be performed before the litmus solution or after the litmus solutions are confirmatory test. There is no hard and fast rule for the performance of the bromine water test, but it is better to perform it in the beginning, so you came to know that the given compound is saturated, mean, or unsaturated. Saturated means somebody having single bonds, unsaturated means somebody having double and triple bonds. So let me start with that. So bromine water test. Bromine water test. It confirms the presence of saturation or unsaturation in the given compound. The saturation means the presence of single bonds in the molecule, in the compounds. The unsaturation means the presence of double or triple bonds in the given compound. This is confirmed from the bromine water test. However, we need to look how it has been. It is confirmed actually what happens inside the test tube. Let's say we have some sort of a compound where the double bond is present. When you put in bromine water, that is supposed to be Br2, what happens actually inside the tube. I would like this way. You have put in your organic compound inside the tube, and then you put in bromine water into the tubes. How they actually react with each other? I can write this Br with this Br. These the pi bond electron, the pi bond between carbon and carbon in the form of a double bond attacks at the benzene bromine. It goes out in the form of bromide. What happens then? You have substituents around. This Br gets attached with this carbon. This electron has been taken from here and been given to this Br. Consequently, this carbon has lost electron, is supposed to carry the positive charge. We have an idea this Br is in the form of Br negative and is around in the same test tube. So what happens then? This bromo attacks at this carbon again, and what happens then? It gives you this sort of product. Mean bromine got added on alkenes. The alkenes has undergone an addition reactions. So when this addition has happened, when the molecule carries double bond, or the same could have happened when the molecules contains triple bond. So this bromine can undergo addition reaction. So this is how this bromine Br2's original color is. It has an original color, brownish color of the bromine water. When it reacts, the breakage of the bond between Br and subsequent bond formation with the alkene, it results in the disappearance of the color of the bromine water, because there is no more bromine is available in the test tube. The Br2 has reacted with an alkene, so the color of bromine will disappear because there won't be any more bromine available. It has reacted with that alkene or alkyne molecule, so it will not be available. Consequently, its brownish color will be disappear, suggesting that the molecule contains double or triple bond. Why? As it carries double or triple bond, then it would have undergone the reaction with Br2. If the molecule carries single bonds only, let's say, and if you react it with bromine water, there is no reaction center. It can't undergo any addition. The bromine cannot get add at alkanes at single bonds, so it will remain present as such in the test tube. So its brownish color will not disappear. It will persist, suggesting that there is no reaction. Mean bromine is in its original condition, original state, that is Br2, that is of brownish color. So no change in color suggests there is no reaction. Mean there is no reaction, mean the original molecule carries single bonds. So this is how the bromine water confirms the presence of double or triple bonds in any molecule, whatever the nature and the chemistry of the molecule, whether the given compound is some sort of an acid, some sort of a base, it's a phenolic entity, it's a sort of an amine, it doesn't depend on their functional group. It depends only the presence of double or triple bond. If the double bond or triple bond is present, the bromine can attack on that and undergo addition. Consequently, its color will disappear. On the other hand, if the molecule carries single bonds, there won't be any reaction between the two. as there is the bond between Br remains present, no breakage is there, so its color will not disappear, its color will persist in the tube, which suggests there is no reaction, means the starting compound, the unknown compound, carries single bonds. This is how you can conclude from the test whether the compound carries single bonds or double bonds, means the presence of saturation or presence of unsaturation. As I've told you, this test confirms only the presence of uh, double or triple bond, regardless the presence of the functionalities, the functional groups. Let's say we have this sort of a compound. It's some sort of a functional group, some sort of a carboxylic acid having a specific name. I will discuss when we will be discussing the reactions of carbonyl compounds. Similarly, there could be some other sort of compounds like you may have this type of compounds. Similarly, the compounds could be of any type, let's say. Once you react them with bromine, this is the way. We have an idea that's a pi bond between the carbon and the carbon. So as usual, there is a tag from this electron at the bromine, it goes over here. So for your very convenience, I could write it something like that. It's a sort of an acid functionality. This got the Br. And this carbon carries positive charge because of its loss of its electron. We have an idea there is a presence of Br negative in the same flask, in the same test tube, so it can attack over here, giving you the consequent product. So we will have two Brs. So the presence of double bond make this molecule to react with bromine water to give you the corresponding product. However, in this molecule, the benzene is there, the carboxylic acid functionality is there. They won't participate in the reaction. Mean the bromine water test will confirm only the presence of double or triple bonds, saturation and unsaturation. It will not react with any other functionality. Benzene, carbonyl functionality, carboxylic acid functionality, phenolics, alcohols, whatever the functional groups are present in the molecule, they are not going to influence the reaction of bromine water with the alkene functionality. This is the reaction of alkene and alkynes only. Similarly, we have this sort of a molecule again. Let's say we put in bromine water. Again, we have an idea, the carbon-carbon double bond. It can react in the similar fashion. So we will have, yes, this sort of molecule. This will get bromo. This will get initially positive charge. This negative can attack over here and giving you the final product, something like that. Similarly, if I can show you the last molecule where an alcohol functionality is present, then single bonds are present, there is a presence of double bond. The presence of double bond is vulnerable for reactions with bromine, so the carbon-carbon double bond will react with bromine, as we have an idea. We will get a bromo here. Either is supposed to be positive, then the Br negative is supposed to attack, and consequently this bromo gets attached over here, so we will have this sort of the molecule. So you see, there are three different molecules. Molecule number 1 carries benzene functionality as well as carboxylic acid group. Once there is a presence of double bond, it reacts with bromine water. The breakage of the bond between Br and Br subsequently discharges its color, which represents the balance of and the reaction of this body with this carbon and carbon double bond, giving us this sort of a product, means that as the reactant molecule carries double bond. Similarly, in this fashion, in this molecule, we have two benzenes around this double bond. So the pairs of double bond could react with the bromine water, giving you the corresponding product. Due to this one, no influence, no participation from benzene. Similarly, alcoholic molecule carry single bonds as well. There is a presence of one double bond. It reacts with bromine water. It reacts with bromine water, disappears, discharges the color of bromine due to the breakage of the bond between Br and Br and the formation of the resultant such molecules products, which suggests the given molecule was an unsaturated. What was that? Alcoholic molecule, or the given compound is some sort of an alkene or some sort of a carboxylic acid. We cannot predict the presence of these groups during this reaction with benzene because they remain silent. Once we perform bromination with any sort of a molecule, only the alkenes and alkynes, they are supposed to react with the bromine water. The rest of the functionality remains silent. They are unreactive. They don't participate in the reactions. As they don't participate in the reaction, so we can't predict their presence, mean we can't confirm their presence in the molecules. That's why we need other confirmatory tests for to check or to confirm their presence in the molecules. Let's say in this molecule, the presence of carboxylic acid functionality, that's definitely going to be confirmed initially by the litmus solution, as it will detect the presence of acid. Then further, due to this carboxylic acid functionality, it will be confirmed by the sodium bicarbonate test, because that test specifically acts at this site, so it will be confirmed by that. Similarly, in this molecule, it's an alcohol. This alcoholic functionality, which do not undergo any sort of transformation, any sort of interaction during reaction with bromine water. That's why its presence will not be confirmed by bromine water test. So that's why bromine water test only confirms the presence of double bonds, triple bonds, because it can react only with the double or triple bonds. It cannot react with any other functionality. As it cannot react with any other functionality, so the other functionalities cannot be detected. So this test only confirms saturation or unsaturation. For the confirmation of the other functionalities, we need to bring in the specific tests, like tests for phenols, tests for carboxylic acid, tests for amines, confirmatory tests for aldehydes and ketone, this and that. This is how you need to move on. So this is what I'm trying to convey you guys. The bromine test, the chemistry behind the bromine water test, which confirm the unsaturation or saturation of the given compound. Once you perform this test, you can simply came to know that your unknown compound, which is unknown to you, given by your instructor, given by your lab chemist, that is a sort of saturated or unsaturated. Whatever the other functionalities are, they need to be confirmed by the other relevant corresponding tests. This is how I'm trying to convey you. Okay, one thing came to my mind. Let's say I've discussed this sort of a molecule just with you, carries double bonds. We perform bromine water test with this buddy. I've told you this pi bond, pi electrons do move towards the bromine molecules, and subsequent steps are performed, and the product formed represents the presence of unsaturation. In this molecule, we can see there are 3 double bonds are also present in one benzene. The other benzene also carries 3 double bonds. The presence of double bond means they are also supposed to undergo reactions with the bromines, brominations, addition of bromine, actually, bromine water test. But we have ideas benzene do not react with bromine. Benzene's bromine water test is supposed to be negative. Once, let's say, you have a benzene and you perform bromine water test, it will not, no change in color. There will be no change in color of bromine water, mean it will remain brownish. Why? Because there won't be any reaction. Bromine water, bromine molecule will not react with benzene. That's why the color will not disappear. Why it will not react? Because, as I've told you earlier, you have an idea from your physics classes as well, that the benzene's double bonds in actual are not true double bonds. They are not true double bonds. They are a sort of a resonating, more like single bonds. They are not true double bonds. As they are not true double bonds, that is why they do not react with bromine molecule, and they do not discharge the color of the benzenes, because benzene is not an unsaturated molecule. Benzene is supposed to be a saturated molecule, because the double bonds are not true double bonds. As they are not true double bonds, they cannot react with benzene, bromine water. Subsequently, no products formation could happen over here, no reaction, which suggests that bromine is insensitive, inactive towards bromine molecule. As I've tried to convey to guys, the bromine molecules are supposed to react only where double or triple bonds are present. Otherwise, they are insensitive towards any other sort of functionality. So this is what I'm trying to convey you guys about the chemistry of the bromine water test with the different type of molecules. Whatever the chemistry of the molecules, the bromine molecule reacts only with double or triple bonds. Once it reacts, the bond between Br breaks down. The breaking of the bond results in the disappearance of the original color of the bromine molecule, which suggests there is some sort of reaction. If there is no reaction with the benzene and the molecule, then the bond between Br and Bl will remain, will persist. Similarly, the color of the bromine will not disappear, so it will represent the molecule is saturated, there is no double bond. So I hope you got the idea about the chemistry behind the bromine water test. If you have any question, you may come up, please. You may approach me through email or my WhatsApp number, or you can put your question in the comment area. I will be really happy to respond your queries at the earliest possible, please. And I hope that today's lecture would have cleared your concepts regarding the bromine water test, which is very much basic for the lab activities at your level. Thank you very much. Assalamu alaikum.